Good evening, everyone. This is Eshan Rao. I'm a PhD student from Indian Institute of Technology, Tirupati. So this is the fifth live interaction session that I am taking of the part of NPTEL Data Analytics with Python. So in this session, we are going to solve some question with respect to Central Limit Theorem, standard errors, confidence level, interval, hypothesis testing, and all those things. So we will get each of this topic with one, two question each. So uh, we are going to discuss a lot of topics in this session. So for this, I have prepared a sheet which I will give the link here right now. Just a minute. Let me. Okay, so I just gave the link of the sheet that which I am going to use right now. So this is a 2 hour session followed by like in which 10 minutes will be taking break around 6:55 to 7:05, and we will solve questions according to that. First thing, I hope you can hear me clearly. If anyone can hear me clearly, please type out in chat. Can anyone hear me clearly? Okay, thank you.
Yes, sir.
Okay, thank you. Okay, so what I'm going to do right now is I will discuss very in brief about the topics about the topic that I'm covering, and then we will start solving the question. So first is central limit theorem. So this theorem states that suppose you have some population distribution. So, and you will have some sample distribution. Okay, so what it says, central limit theorem says that if given a population p, I am taking any sample. So in this there are few conditions are there. So for example, if my population distribution is already a normal distribution, if it is a normal, in that scenario my sample distribution will also be normal. Okay, 1 second. Okay, sorry for I think my network is little bit unstable, so give me a time. It will present right now. Yeah, so I was saying that if we have a popular distribution which is already normal, so if we take any sample distribution, it is meant to be a normal distribution. That's for any n value, for any sample value n, sample size n. So that's what generally we say, but the interesting part will come here, that if I have a distribution which is a uniform, or if it is a exponential distribution, or any distribution, like we can the form can the distribution, the population can be has distribution in any such way. In those scenarios, if my sample size, let's say n, is greater than, if sample size I'm taking is more than 30, then the sample distribution which I'm going to create is going to be normal distribution. Okay, so irrespective of whatever population distribution I am having on the left hand side, if my sample size is greater than 30, then I have a normal distribution. If it is less than that, then we have to use something called student tree distribution. We will talk about that also in the upcoming uh, time. So another point is, if I have a population P and I have a sample something called S. Now we usually have to what has been observed here, that as my sample size n, increases, I will have certain mean of that sample size. This is a sample mean, mean of sample distribution. Okay, if you got this, as my n is increases, my sample mean will tends towards to mu, which is it is called population. It's called population mean. That means the more sample size I increase as a taken a sample, the more I can say with confidence that it is nearer to the actual mean or the population mean. Population mean we will consider as the actual mean here. Okay, so how it can be we can tell them, it can be tell using something called a standard error. So the standard error is usually for a sample, for a sample for example, if I have to get standard deviation is equivalent to standard error. So we usually call standard deviation as error, because our mean is the actual value, and from where we are seeing whatever the differences I have using standard deviation with respect to mean. So if I have this for a standard deviation, I have a mean. Standard deviation for a sample distribution. I can calculate it using standard deviation of original of population, given I know this value, and with sample size. N is sample size. Okay, so standard deviation by root n will give me a standard error or standard deviation for a mean sample mean. Okay, now another observation that we have what has been observed is so if my sample size suppose is 10, my distribution will look like this, a little flat, no, but normal distribution. Assume that distribution is normal. If my sample size is little bit average, that is around 30, it will become little bit. Check the peak point here. But if my sample size is suppose 100, the peak will be very high. So I will say like this, like this. Now the thing that you have to observe is, the more the spread out, the more the standard error. Here we have high standard error. Here the standard error or the standard deviation we have less. So I have a less standard deviation from the population mean that I am. So if we take higher the sample size in any in while doing any statistic from the population, the standard error that we're going to get or the standard deviation that we're going to get, it's going to be less. Okay, so now that being said, let's there are few other things that I want you people to remember, like there's something called as z table for this is for negative. So if I have a normal distribution with here as mu, the left side part usually come towards the negative z value. So the z score, if you have observed the z score that we calculate, z score will be like x minus mu divided by standard deviation. So if you're going to have this and using this, we find usually the z score value. Now to find the z score value, whatever value you can get from here, we can find the actual value from this table. We don't have to calculate, we just have to trace this. We have to find the exact z value from which we can find the area, that is the area under the curve. So for example, okay, I think my net is little bit is doing. So what I will do, I will just turn off my camera. I think my screen is stuck right now. Now it can come. Yeah. Okay, so for example, if I have again if I have a mu, if you can see the left hand side, right hand side. So here, if yeah, I know. Sorry, my unfortunately my net is little bit unstable right now. Once I hope it will be over in within few minutes. It's not over. Please let me know one more time. So suppose I have a z value here, like on the left side of the mu, and I have to so since it's a distribution, we have to find the area under the curve, that is the highlighted part. So for this, if I have the z value, I can find the area under the curve using this value that I am having, using the z table. Okay, there's something called as t table also, which we are going to discuss later when we come to t distribution. Okay, so this is a t table. We will come to it how to read this t table as well. Z score table, I think you might have already used in while solving the question. Otherwise, we will see that thing while solve the question as well, if you haven't used z table earlier. Okay, now that's okay. So let's look at the first question. So the first question, it will be related to central limit theorem itself. So question is, the entrance exam score of a certain university have a mean of 74 and standard deviation of 6.8 and follows a normal distribution. So it is already telling which distribution that we are having. So we have 4 questions, so let's solve it one by one. So like, if a student is selected at random, what is the probability that his score is less than 65? So let's just write it on whatever the information that is available to us. So we have population mean of 74, because we don't, how should I know this is a population mean? Because there's no sample is given. So we will discuss about more in population mean and sample mean also. Now standard deviation also of the population is 6.8. That is already given from the question and it's follow normal distribution. Now the question is, what is selected random, what is the probability that his exam score is less than 65? So if I have a x as a random variable which tells the score of a particular student, I am telling the what is the probability that it is the student score less than 65. So if I have to plot it here, so let me plot it here. Mu will be something, and then since mu is of 74, so obviously I have to check the left side of the normal distribution. Here I have to find that somewhere here it will be 65. So I need to find the area of this area under the curve from 65 to the left hand side. So for that I need to convert. What I need to do, I need to convert that to z score. So what I will do is, now z score will be like z less than x minus mu divided by standard deviation. So if I do this, so just plot all the values here. So it will be p z less than 65 minus 74 divided by 6.8. So if I do this, if I solve this equation, it will be like p z less than minus 1.32. I just need to calculate this value, and once I do this, I need to check the 1.32 value in the z table. So to do this, let's go to z table. So here I have to find 1.32. Okay, so in the z table, what you have to do is, you have to first look at the first column, and okay, you have to look at the first column, and okay, I think screen is not changing for you people. Just a minute. ये नेट आ रहा है क्या अभी? Okay, I request if anyone is opening the video, please stop that video, because I think I have some issue with this internet. Okay, now I have to find minus 1.32 value from z table. So first I have to do is, I have to look at the first column from z table. I have to check minus 1.3, that is there, and from top of the first row I have to check it's 0.02. So you have to check this 0.2 from the first, and then I have to check what is the value I have. So in this case 0.934 is the value that I need. So for the z, which is less than 1.32, if I have to find the area, the area under probability for that thing is 0.0934. So what I have to do is, I have to apply this value in the question. Okay, so here if I apply this, so according to Z table, the value will be 0.09342, which is equivalent to 9.342%. So 9.342% means that there's a almost 9% chance that if a student selected at random, the probability that his exam score is less than 65. Okay. Now, the next question is, if a sample of 50 student is selected at random, what is the probability that samples, now they are already giving a sample for us. Now if I have a sample of 50 students, that is n is equal to 50, and what is the probability that the mean score of this group is greater than 75. So let's dot down what is written given for us. So we have sample score of 50 and mean is given 74 for us. Now what we have to sign it, if the we have to find the sample mean which should be greater than 75. That is the mean of this group, score of this group, that is sample group, is greater than 75. So if I have to plot this, so what I have to plot this is, I have to plot this quotient. So it will be like mu, that is with 74, I need to find 75. For if I have a population mean of 75, find greater than 75, I need to find area of this. But for the Z table of the right hand side of the shaded portion, but for the Z table we usually get the area of left hand side. So what we can do is, we can write this equation as 1 minus p mean will be less than 75. So if I find the value of this, if they find the value of p of this term, I just have to minus it by 1 and then I can solve the question. So to this I have to, let me convert it to Z score. So it will like 1 minus p z is less than x bar minus mu, and here since I have a sample, standard deviation by root n. Okay, so once I have a sample, so how I should find how should I find the Z score will be like x minus mu x since n is already greater than 30, so I can assume that this mu x bar will be equivalent to mu, so x minus mu bar, and instead of standard deviation of the population, what we have to do, standard deviation under root by root n. This is the formula that we have to use if I have a sample, since it is a sample we are observing with. So let's put all the values here. So it will be like 1 minus p z less than, it will be like 75 minus 74, standard deviation is 6.8, so 6.8, n is 50, so under root 50. I need to solve like this. Okay, once I'll do this, the value will turn out to be, if I solve this equation, then the value will turn out to be z less than 1.04, less than 1.04. Now if I find the Z value here, which I found it, so it will be right 0.8503. So if I found the value, so for p x bar, that is sample mean which is greater than 75, will be 0.14917. Okay, so this is for the B part. Now okay, just give me a minute then. नेट आ रहा है अभी? ओके, बहुत चल रहा है. Okay, I have changed the network, so if again it comes, please tell me. Sorry for the inconvenience right now. So right now is my voice clear? better than earlier? Please type down in the chat. Yeah, better. Okay, let's hope that this network stays better. Okay, so let's try the third part of the question. So we have to find out what is the distribution for the mean exam score of 50 students. Okay, so we have to write the distribution. So I will tell you that we have to write the notation. So to write the notation, we just so for the C part. Okay. Okay, so to write this notation will be written as if I have a sample mean. So since it is n is greater than 50, we consider that typically considered as a normal distribution. So we'll write n outside and underscore inside the braces we have to write the mean and standard error. So standard error will be for with respect to the sample. So this will be the mean and x bar mean sample mean, and this will be the standard error. Now since n is greater than 50, we usually write mu x bar equivalent to mu, that is the population mean. So if we just plot this value here, so it will be like x bar is equivalent to normal distribution of 74 6.8 under root 50. If we calculate this, it will be like the mean is 75, right? No, score of 50 student, that's fine. So 74 and 0.9617, this is the answer. So if you have to tell that a distribution, you have to define as a notation, you have to use this the random variable, that is x mean, with n represents a normal distribution. Then you have to give the sample mean mu x and what is standard error, but that is standard deviation. So if you find those values, we just have to put them in the braces. Okay, now the fourth question is find the 80th percentile of the mean exam score of the 50 students. That you have to find the 80th percentile. Okay, so let's plot it to understand what is 80th percentile here and what exactly we have to find here. So for the D, so if I have a normal distribution, at mu usually I have a 50th percentile. This is 0th percentile as starting, and at the end it is 100th percentile. Okay, so to find 80th percentile will be somewhere here, that is 80th percentile, and I have to find the x bar in this case. So I need to basically find the area under this curve till 80th percentile. That's the question they are asking. Find the 80th percentile of the mean score exam. So I need to find x bar. So basically, if I know this, I can know that what is the area under this. To do this, so if you find this, when we say 80th percentile, that means the area under the curve of shaded region will be 0.8, because at 100 percentile it will be 1, exact 1. So we can say area to the left will be 0.8, and to find the x bar here, we have to use the formula of mu, that is mean, and z score of standard deviation. Now how we can find the z score here? So this is the formula that we have to use. So the standard deviation of the sample mean, population mean, and the z score of that. So z score of that will be find using this area of 0.8. So that means I have an area of 0.8, so I have to find the corresponding z value of 0.8. So if I go to the z table, which will be here, I need to find the value which represents 0.8. So which will be in this case uh, here. If you can see this 0.7995, which is almost equivalent to 0.8. This is the area under the curve that we are having. So to find what is the z-score, we have 0.8 here and 0.04. That is 0.84. So that is a z-score value for the area of approximate 0.8. So let's put this value here. So I found z is equal to 8.4. Okay, now I just have to put all the value. So x bar equal to 74, and that is the mean that we have given earlier in the question. Z value is 84, and I have to find standard deviation of x bar, which can be written as 74 plus 0.84 standard deviation of population divided by root of sample size. If I apply this values here, 84 0.68 by root 50. If I solve this quotient, so I will get that x bar is equal to 74.81. So this value will be, the x bar will be 7.81 at the 80th percentile. Okay, so I am just waiting to reflect on the screen. Okay, again quick checking, my voice is clear because I can see that it's not reflecting, anything is reflecting on the screen much for showing later, so I'm so sorry for that. Is my voice is clear at least? At least we can solve based on that. Okay. The only thing I can see here is these are in my second device. I cannot see whatever I'm writing on the real time. It's showing little delay. Okay, let's hope that it fixes over the period of time. Okay. Now same amount of question. Let's try one more time to get much better analysis for that. Okay. Now there's a question is the amount of carb found in a snack bar is produced by company XYZ follows a uniform distribution. So they are giving us a uniform distribution with a minimum of 21 grams to 29 grams. A sample of 100 snack bars is taken for analysis. So the question they are asking one by one. So we will solve it one by one. So let's write what is given written for us. So we are saying that they have given amount of carb we can find carbohydrates in a typical snack bar. So for that they have given this uniform distribution. So if you know from previous case, uniform distribution is kind of rectangular distribution where our probability is constant here. So here on the x-axis, that is the amount of carbohydrate it should have. So it is given from 1 grams to 29 grams. Okay, so this is that is given the question. So from this we can write that. So first question is what is the distribution of amount of carb found in one snack bar and calculate the mean and standard deviation. One snack bar. So right now since it's saying one snack bar, it's not giving any sample value per se, we consider that as a by default as a population mean. Okay, so what value we have got for A is 1, B is 29, and for probability the density function of this is usually 1 by B minus A. So if we put this value 29 minus 21, we will find 1 by 8. Okay, now they want mean and standard deviation for this. So first of all, and write the distribution. So to write a distribution, we will write it as x u for uniform distribution, and we have to write A and B. This is how we write a uniform distribution. So in this case will be x u 21 and 29. This is how you write a uniform distribution for the given quotient. Okay, now the second step they are asking mean. So mean will be like a plus b by 2. So if we just write the value 21 plus 29 divided by 2, it will be 25. This 50 by 2, it will be 25. and standard deviation will be it's a minus b divided by under root of 12. So if you I put those values here, so this will be like, say, b minus a, 21 by 29 by 21 under root 12 will be 8 by under square root of 12, it will be 2.3094. Okay, now I will just wait to reflect on the screen. So what we have done till now is, the first question they're asking to find the mean and standard deviation for a uniform distribution that is given for a one snack bar, which we generally consider as a population for in this case, and we have found that the mean and standard deviation. So the mean is 25 and the standard deviation is 2.3094, which is right now ready to reflect on the screen. So I will wait for that. Okay. By that time, second question is, what is the distribution for the mean amount of carbs in 100 snacks bar? So that's what it is showing. Let me change this also. Okay, so now distribution of mean amount of snacks bars. Now we have given okay, now it is given that we have taken a sample of 100 snack bars. Now once we have taken a sample 100 snack bar and we have this information already, that is A is 21 grams from uniform distribution, B is 29 grams, and we have sample mean of 25 and standard deviation of the population is 0.2.3094. So once we have this, now we have to find the distribution of the mean amount of, so we have to find the distribution. Now since this is a sample of 100, we can directly, based on central limit theorem, we can consider this as a normal distribution. The distribution which is going to form by normal with using a sample will become a normal distribution. So we can write the distribution as n, it's mean and standard error that we are having. So if you put the values here, so x will be n braces 25 by 2.3094 by under root of 100, because sample is 100, so which will be equivalent to n 25 0.23094. This is the answer for the distribution of mean of 100 snacks bar that we can get. Now let's look at the C part here. So what is the probability that a single snack bar has between 24 grams to 26 grams of carbs? So it is asking for that. So whenever we don't get any particular sample value, if it is getting 1, you consider that as a population mean. You directly apply the uniform distribution or any other distribution that you are having. But if it is giving a sample size of, let's say, 10, 15, 100, 20, like more than it's giving a 2-digit kind of samples mostly, then you started considering that whether the distribution made by the sample is normal or not. Okay, so for the C type of question, so they are asking is, if I have taken a one snack bar, so I'm not considered as a sample, I'm just considering as a population. So from that, they are asking that what is the probability that the grams present in that one snack bar is between 24 to 26. That means I have to find the area under this highlighted region in the graph. So I just have to write it as notation. It will be like x if it is a gram, if the number of grams carbs in grams available for the particular snack bar. If you have this, so it will be written as 24. X is between 24 and 26. Okay. Now usually if you have solved uniform distribution quotient, the area under this curve will be basically area of the rectangle, that is breadth into height. So height is usually is 1 by b minus a, which is we have calculated as 1 by 8 already, 1 by 8, and the base will be 24 minus 26, so 26 minus 24, so it will be like 2 by 8, which is 1 by 4 is 0.25. So the probability that a bar which has been taken and and we have to find out whether the carbs in it present is between 24-26 grams will be around 25%. Okay, now let's start with D question. So the question is, find the probability that the mean amount of carbs in 100 snack bar is between 24.9 grams to 25.1 grams of carbs. So they have given us a sample right now of 100 snack bar. So first of all, since it is sample size is 100, so we should all assume that it's greater than 30. That means it might be a normal distribution. Then we have to find the probability of the area under the curve in that distribution. So if we have to plot this this quotient to the graph, it will look like so. So this is my normal distribution for the sample size of 100. So if I have this, let's suppose somewhere it is in this graph 24.9 grams and 25.1 grams. This kind of values is given between them. So it is asking that with respect to the mean of 100 grams, what is the value what is the probability that I can get the mean value within this area with this highlighted area. Okay, so to do this, notationally we have to write that if x bar, which is a sample mean for that 100 samples, whether it's between 24.9 and 25.1 grams grams of carbohydrates. Okay, now I can, since I have to find this area, so I just have to calculate I have to calculate this area and this area. I just have to minus between them. Sorry, not this area. I have to calculate area of this and this. Let me take a different color. So from 25.1, I have to calculate the area from the left hand side, and from 25.9, I have to calculate the area which is shaded in blue, and 25.1 which is shaded in yellow. If I get this, if I minus these areas, I will get the area which is highlighted in red. So let's try to solve it here. So if I have this, what I'm trying to say here is, if x bar is less than 25.1, that is, it is looking at the left hand side of the graph, minus if x bar is less than 24.9, which is the blue highlighted region. So if I find the value of this probability of this area and this area, I will minus it, I will get the highlighted red area. So what I have to do is I have to convert this into z-scores, and then I have to solve the then I find the z values based on which I can get the answer. Now z-score is usually x bar minus mu divided by standard deviation divided by root n. Okay, so this x bar we have in this case 25.1 and mu is 25. X by 25.1 or 24.9, and standard deviation is 2.3094, and our n is 100. So if you apply all this value, let me write it down here, it will be like p z less than 25 minus 0.1 minus 25 divided by 2.3094 by root 100 minus p z less than 24.9 minus 25, 0.3094 by root 100. If I do this and if I try to solve this, the value will, if I solve all this value, it will come down to z less than 0.43. You have to do the calculation by calculator. I have done it already, so I am writing it down directly. It will be like minus 0.43. So if I find the value of 0.43 in the table, the area for the this z value, I can get the answer. So I written that already the answer, that what is the value of z for 0.43 and minus 0.43. It turns out to be 0. For positive it is like 0.666664 minus, for this it is like 0.3336, and if I minus this, the answer will be like 0.3328. So what does it mean is, if I have a sample of 100 snack bar, and I have to find that what is the mean of this 100 snack bar, and it should come between the values of 24.9 and 25.1, the probability of that will be 0.3328, that is approximately 33%. So if you have any doubt until now, please let me know. I will try to clarify it, because it requires a lot of calculation. So if you are missing anywhere else, please let me know. Okay, so now the fifth question is, what is the distribution of sum of carbs found in hundreds of snack bar? So what is distribution sum of carbs? So it's not mean, it's sum. Okay, so it's sum of carb they are asking. So let me write down notation. So it will be based on like sum of carb will be sigma of x. Okay, and it is asking normal distribution of mean of sigma of x and standard deviation of sigma of x. So here mu of mean of sigma of, that is sum of carbs, will be like mu into n, that is what is the mean I am having into the sample size that I am having. So sample is 100 and mu is 25, 25 into 100, 2500. The standard deviation of sigma will be like mean into n. So here this sample of standard deviation, that is 0.23094, that we have found from, if you can write this into sigma under root n, the standard deviation of sample mean into 100. If you do this, if you can get 23.094. So for this, for a sum of carbs for a mean distribution, for a since n is equal to its normal distribution, it will be like 2500, that is the mean of the sum of carbs, and the standard deviation will be like 23.094. Okay. Okay, now the last question in this. Okay, so find the probability that the sum of carbs found in 100 snacks is greater than 2540. Okay, so like the sum of carb that we have found at sigma x. So we have to find, if I have a sum of carb of 100 snacks, I have to find what's the probability that is greater than 2540. So to do this, the notation will be like P of sigma x will be greater than 2540. Okay, so I can find out this value by converting it to a z-score. So how I can convert to z-score? So here in this case, z-score will be like sigma x into mu of sigma x divided by standard deviation of sigma x. So these value we have found here, mu sigma x and standard sigma x, and sigma x here is 2540 is there. So I will write it at like p z less than 2540 minus 2500 divided by 223.094, which is equivalent to p. Okay, I have to be sorry. It should be greater, because it's asking whether the sigma summation of car is greater than this amount. So z will be like 1.73. Okay, so once I have this, usually the z-score, if you have observed z table, usually it's given area of under the curve from the left hand side. Usually it's given, if you find any z-score value, the values of area under curve usually from the left hand side till that point. So if you get that value, you can find out any value for z greater than value. So what you have to write is p. If p z is greater than certain value is there, so you have to write p1 minus p less than z less than 1.73, which is turned out to be 1.01 minus 0.958118, which turned out to be 0.04182. Okay, let me see. Okay, still not reflecting on the screen. Um, just a minute, I'm changing this. Okay, so to summarize what I have done in this for the sum of carbs, that it is sum of carb is whether its value is greater than 2540. For that we have find a z-score value. For z-score value, using this formula, which has for the mu of sigma of x and standard for sigma x, we have found earlier on the top using the formulas that we are having. Then we found that since z value is greater than a particular thing, because we found more than 2550, if you solve this equation, we found that p is z is less than 1.73. But in a typical z value, you will get that if I have 1.73, whatever the area under curve you get will be from the left hand side. So what you have to do is you have to find that value, you have to do is 1 minus p z is less than 1.73. That is, I just have to find what area under this below the 1.73, and I have to do subtract it by minus 1. Whatever the value I'll get is the final answer. In this case, 0.04182. Okay. If I'm going over the head, please let me know, because I've solved lot of calculation plus this internet fluctuation. So if any part of the question you are not able to understand, please let me know. And another thing, that since many people are joining this time, I've shared the sheet link earlier. Let me share it one more time. So I'm using the sheet link to solve the questions. Okay, so right till now it's already 6:50. So we have solved two questions with respect to central limit theorem, and two questions with respect to central limit theorem. Mostly it's a lot of questions that is happening here. So I think within this class we might able to test the confidence interval and marginal of errors and standard errors. So we will try to test that. Maybe hypothesis testing, maybe we will look at the next class. So to summarize, what we have done is till now is we have seen the central limit theorem, which tells that if I have irrespective of whatever the population distribution I am having, whether uniform, normal, exponential, if I have a sample size which is greater than 30, it is considered the sample distribution will be around normal distribution. And based on that, we have solved two questions where either we get the population mean or the population standard deviation. So there is a difference between population standard deviation the and the sample standard deviation. So we have to keep that in mind, and we have solved multiple questions. Okay, so right now what we can do is 6:50. We can take 10 minutes break, and we can come back. By the time, if you have any questions with respect to this, we can discuss. What I will do is I will skip maybe the question 3 for now. I will start with the standard error questions, and I will keep on solving. And another thing is, while uploading this in YouTube and this, I will solve all the questions on this in this PDF itself, and I will upload. Okay, so we might skip some of the thing because of internet issues and all, we are delayed. I'm going behind the schedule. Okay, so I'll solve all the questions. Maybe in the next class, if you have any questions which I'm not able to cover in this topic, we will discuss that. Okay, so 10 minutes break till 7. By the time, if you have any question, you can ask me in the chat, or you can unmute yourself as well. So we will start at 7 p.m. Mostly I want to cover the hypothesis testing. So what I will do is I may cover few of the questions in confidence interval thing, then followed by, because in confidence interval also we have different kind of questions. So I will try to touch one or two questions, then an even student tree distribution. I think I will cover maybe half an hour. Then after half an hour, I will skip rest of the questions. I will go to hypothesis testing. Okay. Th- this internet is killing me. Yep. Too much disturbances, too much fluctuation forming. If you okay, so if you want, I can increase the level of questions. If you want that, I can mostly will try to do that. Sure. So I'm trying to cater like in terms of static, I'm trying to see that most of the people can understand the questions. So that's why if you want, I can increase the level in the upcoming class. Sure, I will do that. Okay, so we will start uh, right now. So what I will do is, since we will I want to cover most of the hypothesis and test 1, test 2 type of. I want to do little bit discuss around hypothesis testing, so I may skip certain concepts or certain type of questions. uh, what we can do is, like, I will, once I solve it, I will upload it. Otherwise, if you have, if since I have shared that sheet with you, if you have any particular question, any question, we can discuss after the session is over. Okay, so I will try to touch few questions. I will try to do over quickly, so that we will reach to hypothesis testing part. Okay, so first is confidence interval and the margin of error that we are having. So usually the confidence interval or confidence level that we are having is just for that, since we are taking samples, so we don't know that whether sample is true or not. So at that point of time, we need to be certain that with certain confidence interval, what we are doing is correct, right? So let's start with this. So the first question is, the average test score in physics class is normally distributed and standard deviation is 5.4. So we don't know the full class strength. So population we don't know. So but we have a standard deviation of 5.4, and we got the sample size of 50. So it's called 50 score with sample mean 75 was selected at random. So out of n number of like population p, we are taking sample of 50 scores, that is n50, and whose sample mean is 79. So find a confidence interval for the population at the mean score. So in this scenario, what they are actually asking is, if I have a population mean called mu, what is the chance that the sample mean, that is 75, and plus with some standard errors, that is minus, in this case, of sigma of x, and not exactly sigma of x. This, according to the confidence interval of particular mean, will be like sample mean minus z raised to alpha, that is z score of a particular significance level, and sigma divided by under root n, and x plus, say, sample mean plus say z alpha sigma root sigma divided by root n. So this is usually the confidence interval we found for the population mean. Okay, so what we are trying to do is, if I have a supposedly mu as normal distribution mu, and I suppose that somewhere here I have a sample mu of 79. So I just want to know and I have given the confidence interval that with 95% confidence interval, what will be my population mean test score. So I have to find, given a kind of range in which I can tell that within this range I can tell with 95% sure that my population will be here, within that area, highlighted area. So when we write this equation, it's basically written as x bar into margin of error, that is this z alpha into standard deviation divided by root n, or sigma by root n, is basically uh, margin of error. So we try to find x bar plus or minus margin of error. Okay, that's what we usually do for any confidence level interval. Okay, so someone has raised the hand. Please, you can type in the chat or let me know by unmuting yourself. Okay, so now once we are having this, and we have a confidence interval, confidence level, basically CL I'm writing as confidence level, it will be like 95%. So to find that, what does it mean? So how to find this value is, first we have to find Z alpha. So we have to find Z alpha. So what does it mean Z alpha is? So in typical case scenario, this highlighted region will be considered as 95%, and this will be alpha by 2 and alpha by 2. So what does it means is, if I have a confidence interval of 95, so within a normal distribution, 95% of the area will, I can say for sure that the mean will be within that region. and they will be alpha by 2 region, area of region, which I don't know anything about right now, that which I can say that this 5% of the region in this case. So if I have 95, so here it will be 2.5% and 2.5% of the region, where I can say that my mu, I'm not confident that mu will be present in this region. Okay, so what I have to do while solving this question, especially to find z alpha, is I know that area. So for that I will use this AL is area, so I will use confidence level 1 plus confidence level, that is CL, and divide by 2. So I will tell that why I'm doing this. So CL is 0.95, so 1 plus 0.95 divided by 2. So what right now by AL, that is area of the region, what I am trying to do is, if I solve this, it will be like 0.795. From here certain z value, the area under this region right now I want to find that. So once I find this area of region for this z, I can identify the value of the region for this z as well. That is by symmetry I will get this minus z value. So I just need to find the value of z, and I have to, for that I have to find all the area under this highlighted region. Okay, so for this 0.75 value, my z value will turn out to be 1.96, I guess. Yeah, 1.96. So this is something you should, the more you solve question, you will try to remember that for 95% confidence interval you might get z value of 1.96. For 99% certain value will be there. So the more you solve question, you will directly remember 1.96, but to solve how we arrange to z value, we'll get this, that is here it's 1.96 value. So here z alpha will be 1.96. Now in this formula, now I have to find standard deviation for the sample mean. So for that I have to write sigma by root n, which will be like 5.4 into root 50, which turns out to be 0.76368. So for the interval, confidence interval that I am having, so what I have to find is sample mean of, that is x bar, and here z alpha standard deviation, that is sigma, divided by root n. So here in this case if I put all the values, 79 plus minus 1.96 into sigma will be sigma by root n I found already here, so it will be like 0.76368. So if I find this value, so if I try to solve this value, that will be here, it will be like 79 minus 1 point, if I solve this, it will be right 1.4968, and mu will be like 79 plus 1.4968. If I solve this, so mu will be turn out to be 77.50302 mu and 80.4968. So what does it tell? It tells that given a sample mean and the sample value, for the typical given population mean, my population mean will be with a 95% confidence, I can say that it will be between the value of 77.5 and 80.49, which is 80.5 value. Okay, that's how we find the confidence interval, and the margin of error will be z alpha into 210. So if you find this, we have found this here, that is 1.4968. If you put this value, we can find this thing. Okay, now I'm skipping this, is again this almost same question to find the confidence level for the 90. If you follow the earlier procedure, we can find it. Okay, so yeah. Z alpha in this case? Okay, Z alpha is basically 9%. Okay, Z alpha. Okay, so let's calculate if you want. So Z alpha would be, for that you use this formula of AL, that is AL is area basically, 1 plus confidence level. Confidence level is 90%. So it's like 1.09 divided by 2. Here you will get value of 1.9 divided by 2. 1.9 divided by 2 will be like 0.95. Now for area of 0.95, the z value will be around, let me see.
So we can do this in Python.
Yeah, you can do all this thing in Python. The reason I'm not solving is because if you don't know this procedure, it will directly calculate and you will not know how it is actually coming. Okay, so here if you have a 0.95 value, so what you have to see here is 0.5. Okay, since I don't have exactly 0.5 value, I found that here at 1.6 line row, and there are two values which is exactly near to the 0.95. So what I can take is, I can take these two values, that is 1.6 uh, 04, that is 1.64, and 1.65 value. I will take an average of this, so that is plus divided by 2, it will be like 1.645. So for my z value in this case, uh, this in this case the z value will be 1.645, and then you saw, if you put that into the equation of confidence interval, you will find the values. Okay, so I'm not solving this, I'm just told you how to calculate the z value. From once you get the z value, you just have to fill all the this values things. Okay, now this is for how to calculate sample size for given confidence level. Okay, okay, let me solve this question one time, and then let's see how we can go earlier. Okay, I will try to skip one question in between, because I will have to catch some more topics here. So here the question is, the average test score of all the students in certain class was measured to be, of all students is 84, standard deviation is 15, and margin of error is given, that is 5.3.67 with confidence, with a certain confidence interval. So I need to find how many students were there in the class. Okay, so let's write down what we have. We have mean, that is 84, standard deviation, that is 15, margin of error, that is 5.376367, and I don't know whatever I am having. Confidence level basically is 95, that is percent, that is 0.95. Okay, now what I have to find is margin of error. Margin of error usually is written as z alpha, since I have it's a mean, divided by sigma of root n. Okay, now for, so again, if you try to plot it and find the value of CL95, that is here it is alpha by 2 and alpha by 2, 0.025, 0.025. So we have calculated this earlier for confidence levels of 0.95, z value will come out to 1.96. Okay, so I'm not telling the process again how to calculate it again. So once you have this value, so z value you also have it, sigma you have, me you have, only you have to find n. So what you have to do, you have to change this equation basically. To change this equation, let me write, instead of me, I will just write at e. So it's like e equal to z, z alpha under root of sigma divided by under root of n. So what I have to square this value to make it n. To find n, you just have to change some equation. So I'm just deriving it for to understand how we can calculate. So let's square the whole side. So it will be like e square z alpha square sigma square, and it will be n. Root n will become n. And then I have to bring n to here. So I will keep it like e square dot n z alpha square sigma square dot n by n, and n cancel, and then I have to cancel this e square from the right hand side, which I can do from by dividing it by e square dot n by e square z alpha square sigma square by e square. I do this, so finally n equal to z alpha square sigma square by e square. So if you have the z value, you have the sigma value, and you have the marginal error value with respect to when the mean is given. So this is for population mean. If it is given, you can find the sample size. So in this case, you put this values, that is 1.96 square. Sigma is, how much sigma was there? 15 square, and margin of error is 5.376, 5.367, sorry. And if you calculate this value, it will turn out to be approx 30. Sample size will be 30. So that's how this is a one type of question that you don't know how many sample sizes there or how many population is there, but with margin of error and confidence level, you can find out these values. Okay, so this is one type of question that you can find. This is also maximum sample size. Right now I am skipping this. Okay, student tree distribution. Let's discuss about this. Okay, so in typically where in central limit theorem, when we are saying that if sample size is greater than or equal to 30, you take as normal distribution. Okay, but in t distribution, when n is less than 30 and most probably your population mean is unknown, in these scenarios you will use t distribution. These are two typical contribution that you will find. So, but even if you find n is less than 30, you can usually directly assume that you have to use t distribution here. Okay, so that's a basic of t distribution. So question is, the average weight of students, 20 students, that is sample is given in a certain school, was found to be 165 pounds. Okay, and the standard deviation, and with the standard deviation of 4.5. So this is a sample standard deviation for the sample that we are having. So let me write it down here. So I have n equal to 20, x bar equal to 165 pounds, and standard deviation of is 4.5. So I don't have mu unknown, I have standard deviation unknown of a population. So, and since n is less than 30, I can directly use the t distribution here. Okay, now what I have to find is construct a 95% confidence interval for the population mean. For the population mean, that means since I don't know the population mean, that is mu, I have to find a confidence interval based on the value that I am having. So to make this, basically we have to use this value of x bar plus minus. Here to find this value of instead of z alpha, we will use something called as t n minus 1. I will explain what this is, alpha by 2, and the standard error. Standard error for the sample, since we don't have sigma, this will be take as standard deviations s, sorry, you can write it as x also. Sigma x bar you can write as x for better understanding, and under root of n. Okay, so now what does it, t n minus 1 alpha by 2. T alpha by 2 is the same. So like if I have this 95% confidence value here, alpha will be the remaining part. So since it's symmetrical, it's a normal distribution, we will consider that alpha by 2 in the both the side. Okay, that's for this alpha by 2 is there. Now t minus 1. So n minus 1, which tells about the degree of freedom. Okay, so degree of freedom will be like, suppose I have 3 benches. Okay, student will come and sit on middle bench, student 2 will come on the far left. So when the student third will come, he has only one option, that he has to sit only on the far left bench. So it doesn't have any freedom. But for S1 and S2 student, they have the freedom of choosing any of the benches. So that is the degree of freedom that we are talking about. So in this case also, the degree of freedom for distribution, so when we talk about with respect to, in this case, that 19 for a particular t distribution, we are saying that 19 students will we can choose anyone. Maybe the first one student will be there which doesn't have a degree of freedom with respect to whatever the weight will be like, or maybe it may be like in a similar scale that whatever we have found. Okay, so that's what degree of freedom is, and usually it turns by n minus 1, that's sample size minus 1 that we are having. So why it is needed is for t table. So if you write this values, all these values, for confidence interval, it will be like 165 plus minus t 19, and alpha by 2 will be like alpha is, since 0.95, 0. Alpha will be 1 minus CL, that is constant, that is 0.95, alpha by 2, sorry, equal to 0.05, alpha by 2 will be 0.025, so it will be 0.025, and S is 4.5, and under root of n will be the value of 20. Okay, now how to find this value of t19 comma 0.025? For this we have to go for t table. Now how to read t table? T table usually given in this way. The first column will be degree of freedom that we are having, and the um, right column will be its the values of the alpha. Now what is one tail, two tail? I suppose you may know, but I will try to discuss in this lecture. Otherwise we will maybe skip this point also. I will tell about that as well. So but for now, what the value we have is, so I need to find for t degree of freedom 19 and 0.025 alpha. So let's find it here. So t 19, and I have to find 0.025, that is 0.025. So I just need to do here. So it will be 2.093. Okay, so it will be 2.093, right? Yeah. Okay, so this value I am having here. I think I'm correct. I'm just checking it one more time. Yes, I'm correct. Okay, 0.93. I just need to put that value here. So it will like 1.6, 165. T will be 0.290, 2.093, and 4.5 under root 12. So if I expand this, it will be like 165 minus, if I solve this question, it will be like 2.106 mu, and 1.6, 165 plus 2.10, 106. If I solve this, it will be like 162.894, and here it will be like 167.106. This is the confidence interval that I am getting, and the margin of error will be this value, t n minus 1 alpha by 2 s root by n. So this 2106 that we found here, this value, by solving this part of the equation, that is plus, after the right hand side of the plus minus part, we'll get 2.106. This is the margin of error that we are getting. Okay, okay, any question till now? Maybe little bit. I will send the YouTube channel link as well. I think I'm speeding up little bit, but please bear with me in this case. Okay, let me see anything else that I can do. I can see population one tail, two tail. Okay, okay, one tail, two tail also I will try to check. So what I will do is, rather than, okay, I'm skipping few of the questions here and try to go to hypothesis testing, and based on that I will tell what is one tail and two tail part of it. Okay, so I think that would be better, because that is also a kind of little bit lengthy topic, and I have only half an hour, 40 minutes to be precise. I will do that. For the rest of the questions, I will solve it and I will upload it. Okay. Uh, okay. So let's start with hypothesis testing, which is called as null and alternative hypothesis. So few basic pointers while solving for null and hypothesis pointer is, null hypothesis, which is denoted by H naught, or HO is usually considered as an established fact. Okay, usually considered established fact, and alternative is which is something which is try to uh, disapprove the established fact, either this disapprove the established fact, or a researcher who has a certain theory, researcher theory, like it the researcher will say that okay, I'm assuming this kind of thing should work out. So those kind of if those kind of statement comes, we will consider as a alternative hypothesis. Okay, that is one thing. And another thing is, while solving these questions, if you get mu or mean, consider that as so if you're using looking at the word average, consider as a mean. If you're finding the word percentage, consider this as a proportion. And I haven't solved any proportion value in this class, but I will try to solve some of the questions here. Okay, any other question? Okay, this is one. And usually when a particular fact is given using, suppose mu is in this case 450, if this is one hypothesis, let's say any hypothesis, we are not naming it right now, the alternative or the other side of it will be like opposite of it or the complementary of it. Okay, similarly if I have some value which is less than equal to, so the complement the another hypothesis will be the complementary of that. So and our task is to identify that which is what. Okay, so the more we solve question, we'll try to understand how we can make sense of null and alternative hypothesis. Okay, so this is some background of null and alternative hypothesis. Let's start solving the question here. So null is usually for established fact, alternative is for disapproving the established fact, or if a researcher has a certain idea, certain theory of it, we will consider as an alternative hypothesis. Okay. Okay. So let's assume. So question 15 is like a company XYZ manufactures calculator with average mass of 450 grams. An engineer believes that average weight to be different and decide to calculate the average mass of 50 calculator. State the null and alternative hypothesis. So H0 is null hypothesis. So it's the established fact that the average mass of the calculator is 450 grams. That is average mass. Okay. So alternative hypothesis would be like, since engineer believes that average is to be different, since we have to find the alternative hypothesis will be always the complementary of whatever the sign we are getting here. So whatever the conditional sign we are getting here, it will be complementary of that. So the alternative hypothesis will be that according to the engineer that the weight will be different. That means the mu, that mean of the average mass of the character is not equal to 450. This is the alternative hypothesis. Okay, that's the only thing you have to identify while solving these things. Okay, let's take another question. The school teacher in a school believes that at least 80% of the students will complete high school. Okay, at least. Okay, but the student disagree with this value and decide to conduct a test, state the null and hypothesis alternative hypothesis. So since it's a researcher in this case teacher, it's not established fact, it's something they believe. So what they are saying is that the pass out rate of a high school will be at least 80%. That means in this case it's a kind of proportion, because it's a percentage, so we can consider it as a proportion. So we define usually as P or P cap. Okay, so what is saying that P cap is usually uh, oh sorry, teachers in the school, right? That means it's established fact. Sorry, since it's established fact, like it is believed that P is greater than or equal to 0.8. That is at least. That means it can be more than 80% student also, which will complete the high school. And so if the alternative hypothesis for this will be the student, when the student disagree, will be complementary of greater than equal to, which is less than. So it will be, which is proportion will be 0 less than 0.8. This will be the alternative hypothesis. Okay. So if multiple people are believing something, so we consider as established fact. So based on that, we will keep them as a null hypothesis, and the complement statement of that will be alternative. And consider that this is mu, and this is proportion. P is proportion here. So these are two different aspects when we are studying statistics. Now, a teacher wishes to test that if the GPA of the student in the school is different from 2.7, state the null and alternative hypothesis. Now, here a particular person thinks that the GPA of a student is different from 2.7. That means it is saying that established fact is that usually in the school the GPA is on an average is 2.7, but the teacher is saying that it is not equal to 2.7. So the alternative hypothesis is which these teachers believing is me equal to 2.7. Okay, now how are we going to calculate certain value from it? We will solve question based on that, but I hope you're getting certain values understanding. If a particular person thinks of certain things, we have to see that what is established fact and what is something the particular person is proposing instead of that. So in this, they're saying that the GPA of high school is different from 2.7. Okay, so that is something it is proposing, that will come under alternative hypothesis, not the null hypothesis. Okay. uh, okay, now 18th question. The percentage of residents who own a vehicle in a town XYZ is no more than 75%. So this is a kind of thing which they have understand. They are telling that resident who own a vehicle is no more than 75%, but a researcher disagree with it and decide to survey 100 residents. So here established fact is that my proportion is that the P is less than equal to 0.75. That is that my proportion uh, the resident who own a vehicle is less than equal to 0.75 is my null hypothesis, and the researcher will disagree with it, will comes down to proportion which is P is greater than, sorry, I should write it differently, right? P is less than equal to 0.75, and here alternative hypothesis will be P is greater than 0.75. This is the alternative. So these are some basic questions to understand null and alternative hypothesis. We will try to solve more questions on this to get much better understanding. Okay. Now before this, we have to find something called type 1 and type 2 error. So in simple sense, type 1 error is the null hypothesis is true, okay, but we are rejecting it. Okay. Type 2 error is null hypothesis is false, but still we are accepting it. Okay, we are accepting that null hypothesis. This is a type 1 and type 2 error. So if, I think you have seen the table here. So if we have, let's say, HO and we have true false, and here we have this, and on the first column we will say that reject null hypothesis or fail to reject. Fail to reject is a standard term they are using, the null hypothesis, which is mean the null hypothesis has been accepted. So if null hypothesis is true but we are rejecting it, it is called as type 1 error. Okay. If the null hypothesis is false, well, we are rejecting it, that is correct, we need to do that. Now, but if the null hypothesis is true and we are accepting it, that is correct. But if the null hypothesis is false but we are accepting it, this is considered type 2 error. Okay, so we will see certain questions to see the how to solve this type of questions. Okay, now the 19th question is like this. Let's say the null hypothesis is of HO is John used to car to say John's used car is safe to drive. So I have to find T1 type 1 type 2 error and which error has a greater consequences. So it has given 4 different statements for that. So let's see one by one. So it is saying that first statement, John thinks that his car is safe, may be safe, when in fact it is not safe. Okay, so if it is safe and if it is thinking safe but in actual reality it's not safe, that means it is taking a wrong decision, because if it is taking safe, it is taking for right. So what we have to do in this, if you get multiple choice question, you have to find which statements are correct. So you will exclude those things, and then you will try to focus on which statements are wrong. Okay, so we will try to find which statements are wrong and we will work on it. From there we will try to find which one is type 1 and which one is type 2 error. Now the second question is, so the second part is, John thinks the car may be safe when it is in fact is safe. So if it is safe and it is safe and it is safe to drive, that means the correct statement that John can take the car. Third is, John thinks that its car may not be safe and in fact is not safe. Since it is thinking it's not safe and it's actually not safe, that is also a good decision. Fourth option is, John thinks that his car may not be safe when in fact it is safe. So things that may not be safe, and still it is not, he thinks that it's not safe, that's why it's not going for driving. That means he's taking a wrong decision. So we have 1 and 4 statement in which John has taken the wrong decision, and we have to find that which is type 1 and type 2 error. So like I said earlier, type 1 error is when HO is true, that null hypothesis is true, that it is safe to drive. Okay, so when it is safe to drive but you are rejecting that null hypothesis, it will come down type 1 error. So in this case, it is safe but John is not taking that car to drive because he is thinking it's not safe, so it is considered as type 1 error. Okay, now the first one by default become type 2, but why it come type 2 error is, it is thinking that he's thinking the car is safe, but in reality it's not safe. That means here the null hypothesis is false, but he's still accepting the null hypothesis. It is the null hypothesis is false that because it's not safe, but still it is accepting that hypothesis and taking that car to ride. That's why it is type 2 error. Now, which type of error has greater consequences? In this case, will be type 2 error, because even it's not safe, if he's taking his car to for a drive, then there's a chance that it might go accident, so it might have a higher greater consequences, right? If Because in the fourth statement, if uh, thinking the car not safe, even it's safe, that means he's not taking a drive, that means he's still safe inside his home, but he's taking a broken car for a drive, that is high chances of getting something bad. So that's why type 2 error in this question, for this question, has a greater consequences. Let's try to solve another question. Uh, in a criminal court case, the null hypothesis that the defendant is presumed innocent. Okay, the null hypothesis that defendant who's charged of guilty is innocent. So we have to find type 1 and type 2 error. So there are 4 statements given here. The first statement is, the jury believes that defendant is guilty when in fact he is innocent. The jury believes that defendant is guilty, in fact he is innocent. Uh, okay, is my voice is again lagging? Okay, is it now clear? Like I'm just talking anything. So is it clear now? Okay. Okay, so what it is saying, the first statement, let's see, which we have to find which one is correct and which one is false statements. We have to select the statements which are false, and then from that we have to find which one is type 1 and type 2 error. Okay, so the jury believes the defendant is guilty when in fact he is innocent. So he is going to take wrong decision, that's why the statement is wrong. So this is something we have to look at. The jury believes the defendant is guilty and he is not innocent. So if he is guilty and he is also not innocent, that means it's correct statement. So it's taking correct judgment. So we will not going to think much about it. Third statement is, the jury believes the defendant is not guilty. Uh, in fact, he is not innocent. The jury is not guilty, uh, and he's not innocent, that means he's taking a wrong decision here. Okay, because he's actually he's might be a criminal, and it is but the judge is giving this a not guilty. The jury believes the defendant is not guilty when he's innocent, which is the correct statement. Now we have to find type 1 and type 2 error. So again, go by this, a null hypothesis that the defendant is innocent. So we have to find for in the wrong statement which statements uh, where the null hypothesis is true, but it is still rejecting. So in this case, the statement 1, he is innocent, the null hypothesis is true, but in this case, the defendant is charging them guilty. That means it is a type 1 error. And in third statement, by default, it's type 2 error because it is charged not guilty, but he is not innocent. So that means S2 is null hypothesis already false, but we're still accepting that as a accepting that hypothesis. This comes out type 2 error. I think someone has written the correct answer. Yep, on the chat. Now, which type of error has greater consequences in this case? According to me, it will be type 1 because he is innocent, but we are still charging that person with a crime. That means he has to serve his time in prison. So that this will have more higher impact than a person who is not innocent and is not charged of guilt. He's a criminal and is not charged of guilty. So in this, type 1 has a higher type of consequences, but again it's a subjective thing. We have just kept for the question by question thing. For the it depends on question to question, and usually generally don't they are not asking in the paper. Okay, now we will talk about one tail, two tail test, critical value and significance value. We will try to understand this concept. We will quickly solve one question with respect to this. Okay, that's what we are going to do in this last 20 minutes. Okay, so let's assume example that you have a null hypothesis that the weight of a potato, so the mean of a weight of a potato is maybe 100 grams. This is the potato weight on an average is 100 grams. Now alternative, that means the alternative hypothesis for this will be that mean weight of potato is not equal to 100 grams. So that is something we have this null and alternative hypothesis thing. Now we are saying this we are saying certain things that the null hypothesis is correct with the confidence level of 95%. Okay, so once we have this confidence level and we have alternative and null hypothesis, what we have to find is we have to find out which kind of test we have to apply uh, to find a certain mean or certain values. So what we have to do is, if I have a normal distribution, which in most of the case it will be like, I have a confidence level that 95% of time my null hypothesis is true. So I have to find for the remaining alpha by 2, that is here 5% of time I have to find that what is the value. So and to find those things we do certain test, that is two tail and one tail test. In this case, if I have if I have this statement that is equal to, that is if I am giving equal or unequal statement, in this cases I will do a two tail test. Okay, but instead of that, let's assume that this statement is converted to like this. My null statement is that the average weight of a potato is less than equal to 100 grams. So alternative will be mu will be greater than 100. Okay, so if I am having this kind of scenarios, so I have to find the area of certain z value. I have to find certain z value here, and you find that whether a certain value based on whatever data I am having, whether the population mean is greater than 100 or not. Okay, okay, uh, okay, I can wait for few minutes, few seconds. Now you check whether my voice is clear now. Okay. So what I would suggest is someone is saying the voice is not clear. Please, others, if they are able to hear it clear, please type it out in the chat. Okay. So that the person can check whether they have any issues with network issues or not. Okay. Now, if I have mu, so I have to find that, and with certain confidence level, let's say 95%. Okay. So if I have get this kind of statement that that my potato average weight of potato is less than or equal to 100 grams, so alternative will be greater than 100 grams. So what I have to do is, since it is greater than a particular value, that is value giving, so it will come as one tail test. In one tail test, there is two tabs, left and right. So this will consider right tail test. So I have to find that based on the certain values, I have to find whether my mu value or whatever the value I'm going to find, whether it lies in the highlighted region or not. So this is called right tail test. Let's suppose a different scenario here. So if I have a hypothesis, a null hypothesis that average weight of potato is greater than equal to 100 grams. So my alternative hypothesis is that the average weight of potato is less than 100 grams. So in this case, since it is less than, mu is less than certain value, so it will come down one tail test, but it will focus on the left hand side. So it is a one tail test and usually come down to left hand side, left tail test. It will consider left tail test. So I'm just telling a kind of observation that you get, and based on which you can find a certain values. Uh, I will solve certain portions based on which we can find this. So when we are saying this highlighted region, what does it means is this region will be like fail to reject null hypothesis. Highlighted region will be like reject null hypothesis. So whatever the question that we are going to test in hypothesis testing is mostly like to see that whether within given a certain condition, certain value, we have to see that whether we can accept the null hypothesis or we should reject the null hypothesis. Okay. So in this case, two-tailed test will look at the both side of a normal distribution given a null hypothesis, given that we have a equal symbol or unequal symbol. If this kind of pointers you will get, you consider as a two-tailed test. Now, if you get as a greater than equal to or less than equal to kind of thing, in that case, you consider as a one-tail test. In that also, you have to see that if the particular value, mostly in terms of mean, if it is greater than certain value, you do the right tail test because you have to find that uh, if the certain value is less than, but if mean is less than certain value, you do the left tail test. Okay, it does. Instead of mu, you can find proportion or any other values as well, but look at the greater than and less than value in this case. Okay, uh, let's solve one question to get better understanding of this. uh, okay, right now I will not explain this test statistic. Let directly solve these questions to see how what we can do here. Okay, so a factory has a machine which dispenses 80 ml of fluid in a bottle. An employee believes the average amount of fluid is not 80 ml. So using 40 samples, he measured the average amount of measured average dispensed by machine is 78 ml with standard deviation 2.5. State the null and alternative hypothesis and check at the 95% confidence level. Is this evidence, last two statement of the question, is enough to support the idea that machine is not working properly? Okay, this kind of question you might get. So first is state the null hypothesis. So it is an established fact that factory is saying that averagely I am getting a value of 80 ml of fluid. Okay, so alternative will be that mu is not equal to 80 ml. Okay, and since we have equal to sign, we can assume that we can clearly assume that we have to do tool tail test here. Okay, now we have to conduct two tail test to check that whether null hypothesis is correct or not. Okay, so part A is completed. Now let's look at the part B. So that means 0.95 confidence level that null hypothesis will be accepted or fail to reject, and this here right hand side 0.025, 0.025. I'm assuming that you know that how I'm getting the 0.025, that is 0.05 I'm getting from the reject hypothesis, and if I do divide by 2 I'll get this value 0.025. Now what I have to find, I have to find z value here first. I have to find at what point of z value in the normal distribution from where I can start looking for the areas which are rejecting the null hypothesis. So to do this, let's see whatever the value I'm having. I'm sample mean of 78 and is 40 and standard deviation of the sample is 2.5. This is the value that I'm getting, or you can write it as S. Okay. Now since n is 40, we can assume that it's a normal distribution. Like by default I'm assuming that normal distribution, but based on value, sample value, and only we should assume that it's a normal distribution. Now we should say that we have to find that what is the value of ZC. We have to find a certain value of ZC based on which we can say that, okay, what is ZC here? ZC would be x minus mu o divided by s divided by root n. So what it tells that based on the value that I'm having here, I'm going to find the ZC value. That is one thing using this formula. Okay, and I have to find another Z value here based on the confidence level I am having. Okay, so based on 95 confidence level, usually we find Z value as 1.96, so I can directly put 1.96 here and minus 1.96 here. So now what I have to check is whether this ZC value, what I'm going to calculate, is great if it is greater than 1.96 in this case, or if it is less than minus 1.96, that means I can directly reject the null hypothesis. But if it is in between this minus 1.96 and 1.96, that means I can accept the null hypothesis. That's how it is. So if I put this value here in this equation, so ZC will be 78 minus 80. Standard deviation I am having is 2.5 S, and I have n as 40. So if I solve this value, I will get as minus 5.06. So if I am having this, if you observe, Z is in the left hand side, Z value from where I can start rejecting the null hypothesis minus 1.96, and here I am finding that minus 5.6 will lie somewhere here, somewhere outside this. So I can clearly say that this area is rejecting null hypothesis. So based on this minus 5.06 value, I can say that I can reject null hypothesis with 95% confidence value. So 9% confidence level based on the ZC value. Okay. So again, to summarize, we based on the question we identify null and alternative hypothesis. Based on confidence level, we find the Z value. First of all, we identify which is it's a one tail or two tail test. Since it is equal to, we tell that it's a two tail test because the value can be both at the left and right hand side of the normal distribution. Once we have this, we have to identify the Z value of this, which usually we can find it using Z table. Once we find the Z table, we have to find alternative value of ZC, which we can find from the whatever the other values we are having, that is the sample values, that is sample distribution value. From that we have to find the ZC value, and we have to see that where this ZC value will stand lies in this whole distribution. If it is lying in the rejection area, we will say that a null hypothesis has been rejected. Okay, now let's solve another question before we wrap up this session here. So confusion is not confidence level. No, I didn't understand the question. Can you repeat? Yeah, so we are saying that once we find a particular ZC value based on the sample distribution that we are having, we have to check that with the confidence level. So if it is lying in the confidence level interval area, we can say it's a null hypothesis has been accepted. Otherwise, it has been rejected. Are you able to get it, or shall I explain it one more time? Okay, let's all. Just a minute, someone else's voice is coming.
Yeah, and one basic question, sir.
Yeah, sure.
You said when n is 30, we can take it as normal distribution.
Whenever n is greater than 30, yes.
So if it is less, how do we take it as uniform?
Tree distribution. We have to apply tree distribution concepts there.
Okay.
Yeah. Okay, let us solve another question to see to get more better understanding of hypothesis testing. Okay, question is a company manufactures car battery with an average lifespan of 2 years. It is saying or 2 years or more. An engineer believed this value to be less. So using 10 samples, he measured the average lifespan to be 1.8 years, standard deviation 0.15. State the null and alternative hypothesis, and we have at 99 level of confidence level, is there enough evidence to discard the null hypothesis? So let's see whatever we have. So established factors like that company says that their car batteries had an average lifespan of more than 2 years. So this will be null hypothesis. Alternative hypothesis will be like the which engineer saying that the average lifespan of battery is less than 2 years. So this will become null and alternative hypothesis. Now, uh, in this case, what we have to do is second question is I have a sample of 10, okay, and my average lifespan mean with 10 sample is 1.8 years and standard deviation is 0.15. These values I am having, sorry, s will be there because it's a sample standard deviation, sample distribution, deviation, so it's 0.15. Now what we have to do is first we have to find what kind of test it is. Now since it's greater than less than kind of symbols are there, we can assume that it's a one tail test. Okay, now in that, since the mu is less than certain things, we can tell that it's a left tail test. Okay, so suppose certain kind of distribution is given here, so I have to find the left side of the distribution where I can say that it's rejecting the null hypothesis. I have to find that area here. Okay, so let's see what we can do. So we, and since n is less than 30 in this case, so I have to apply t test here, like t distribution test here. Okay, so first of all, for t distribution we have to find usually degree of freedom, which is like n minus 1, which is maybe 10 minus 1 is equal to 9. That is one. And what we have to find is tc here, which formula will be like x bar minus mu 0 s by root n. Now mu is r is 2 already, mu is 2 here, so we'll lose that. X bar is 1.8, s is 0.15, and n is root 10, so 10, n is 10. Okay, that is one thing we have to do. So we have to use this first formula, we can find tc, that is the value you have to find. But from the graph, what we have to do is so another important thing, that when we have a t distribution, we can say, we can and we cannot say that the distribution is normal or not. So but for solving purpose, we can assume that it's a normal distribution. So again, I'm saying if I have a t distribution, we cannot say that whether the sample distribution is normal distribution, but for the calculation sake, we can assume right now. So how we can find that? How we can find the t value here? That means if I have a 0.99% confidence level that uh, the null hypothesis is correct, so I have to find for 0.01%. Alpha is 0.01%. So usually for t table, for degree of 9 and 0.01%, I have to find a value which can tell me the area under the curve of this, the highlighted region. Okay, so this is for assumption purpose only, but this assumption will help us to understand what is the value here. So if we use t table here with degree of freedom 9 and 0.01, 0.01 here, this. So in this case it will like 2.821. So it's come out to be minus 2.821. Why minus 2.821? Because we are looking at the left hand side usually. Okay, mu will be somewhere here, and we will say it's the left side of the mu, it will be mostly minus 2.5. If it's the right side, it will be like point plus 2.8 kind of thing, just like how you have observed for standard deviations. Now we have to find whether the TC lies on the left hand side of this highlighted region or the right hand side. So if we calculate this value for TC, it will be like 1.8 minus 2, 0.15 by root 10. And if you solve this value, which I've solved, is like minus 4.22. So if I try to plot somewhere here, so minus 4.22 will come here, which is lies on the left hand side of the graph, which tells us that this left hand side, which highlighted graph, rejects the null hypothesis, and this accept the null hyp or fail to reject null hypothesis. So if you find this, so that means TC is less than T9 0.01. If you find this kind of scenario, or in this case if you find it's not in the acceptance region, we can say that with 99% confidence level, we can reject null hypothesis. Okay, so it's already 8. So there are other questions are there that is using p value also, maybe I will cover in the next session. But to summarize, what we have done here is, in especially hypothesis testing, first you have to identify the null and alternative hypothesis. Null hypothesis will be usually established fact. Alternative will be something which try to disapprove the null hypothesis, right? That's how usually. Based on this, we have to find what kind of comparing symbols you are having. Whether if it is an equal sign, you consider as a two tail test. If it is greater than less than sign, you consider as a one tail test. In one tail test also, you have to check whether it's a right tail or left tail. And based on the other values that we are having based on sample, we have to find whether we can reject the null hypothesis or not. That's how the question will be related to it. And in other questions, we have checked the central limit theorem and little bit of confidence interval. There are a lot of variation in confidence intervals and levels also, which I will solve in this PDF, and I will share that with you all. Okay, so that's the end of this session. Thank you. Thank you for listening, and apologize for the internet connection. I will next time I will try to see whether I will get a stable internet connection. And if you have any other question, you can ask. Yeah, please ask.
Yeah, so whenever we reject null hypothesis, it's like we are accepting the alternate hypothesis, or we think that there is no enough evidence
We are saying that
to accept.
based on whatever we are having, date sample size we are having, based on that we are rejecting the null hypothesis. That means we are accepting the alternative hypothesis. That's how you should see that.
Okay.
Based on sample.
Okay, so every time it will be that, and when is it that you can say that there is enough evidence to prove?
No, you are saying that still they are still like in this case there's still 0.1% or 1% of you can say that it's not enough. Still 1% is there where you can say that uh, prove that null hypothesis is not true. You can 100% you can 100% you cannot say that it's not enough. That's why the confidence level is given into 90, 90, 99, 95, 80, because we can say with 99% confidence that it might be true. 1% chances that my sample might be wrong.
Okay. Or
Yeah. Okay. Thank you. So someone asked for the YouTube channel link. Let me post it here. Thank you, everyone. Yeah, I will upload the updated document with this upload after this session. When it's over, I will upload this in the YouTube channel. In that, I will upload the updated sheet, as well as NPTEL will also share this with you. So thank you everyone. So I will just